Hi, can you hear me online?
Yes, sir.
Okay, so shall we discuss the questions? I think most of you have answered each other's doubts, so that is good to see. So, are there any doubts left for me to solve, or everything is done already? And actually, I had asked you to share the questions in advance so that I will get some time to look at the problems, but I didn't get any time. So, I will also have to attempt the questions from you. So, can you suggest if any question which has not been discussed adequately on the group that we need to talk about?
10.
Sorry, can you repeat that?
Question 10.
Question 10. Okay.
20.
20. So question 10 is find the smallest k that a plus b plus for all ten p is okay. So looking at question 10, has anybody solved it or any ideas? Okay. Okay, but how to prove that we don't know. Yes, do you see that AMGM? So Raghav, you have solved this question?
Yes, sir.
Okay.
AMGM only for the 20th question, right? Sorry, the 10th question.
question 10, the find the value of k, right?
Yes, sir. EMGM.
Yeah, okay, yes. So, I mean, looking at the form of the question, right? Left hand side is the sum of some terms, and the right hand side looks like the GP of some terms, GM rather. So, AMGM is the right idea. Uh, so, if you just apply AMGM to these terms as it is, right? What is it that we get? We can look at that, and maybe that will give you some idea. So, we get A plus B plus C. So this is what we get by MGM. And now if we just rearrange that, I mean, things are look to be falling in place because here a square, b square, c square, and the fourth root will become root abc. And then, so we just have to adjust the constant term in the right way. So from this, we can rewrite this and get a plus b plus c plus 4k has to be greater than or equal to 4 times fourth root of k into root abc. So if this fourth root of k happens to be equal to 8, then looks to be on the right track. So for that, what is the value of k that we should use? 16, right? If k is 16, then this term will match. So k, so we can be sure that if k is 16, then this is true. But the question is find the smallest value of k. So can we be sure that we cannot go below k equal to 16? So if you can come up with some numbers ABC such that because the thing is that for every ABC greater than 0, this inequality has to be true. So even if you can come up with one values of ABC where k cannot go below 16, then that is the ideal one. So the question is, can we find what those values of ABC should be? At which we cannot go below this. But is this part understood that k equal to 16 is certainly one candidate? And of course, if you choose k greater than 16, then it will be true because the LHS will keep increasing, right? So 16 and any number above 16 will definitely work. But can any number less than 16 work or not? That we have not answered yet. So I'll just give a few minutes to think. One by four. Yes. And why did you choose that value? Yes, correct. So AMGM, we have to look at the equality case, right? Where all the terms are equal. So ABC we can choose to be equal, but that is also has to be equal to k times ABC. So whatever value of ABC, that will give us that equality. So if we choose 1 by 4, is it? Okay. So if you consider A is equal to B equal to C is equal to 1 by 4, then I think k times ABC will also be 1 by 4, right? Yes. So then this is the case where equality is going to occur. And so what will happen if I substitute 1 by 4 in this expression, see what it reduces to in terms of k. So the LHS will become simply 3 by 4 plus k times 1 by 64 greater than or equal to 8 times 1 by 1 by 8, right? This is what we get. And if I rearrange this, what do you see? What do we get? Actually, we simply get k greater than or equal to 16, right? Okay. So that directly gives us the result that k has to be greater than or equal to 16. Or in other words, if I choose a value of k less than 16, then this inequality won't be true anymore. So that is exactly the border case. Okay, any doubts in this? So Raghav, you did use a similar approach?
Hello? Yes, yes, sir.
Yes, okay. Yeah, I think in this question there is not much flexibility because looking at the form, immediately AMGM comes to mind. And so that is the only way we can proceed. Yeah, and I should say that this is a 2019 paper, right? So 4 years ago. So that was a time when pre-RMO, I don't know which year pre-RMO got introduced, but it was relatively new. So even I didn't have much experience that what is the difficulty level that I should be setting in the practice test. So mostly the questions you'll see are kind of on the simpler side. Even you may feel that in many cases in one step or two steps you get the answer. But these days the IOQM difficulty you can expect to be definitely higher than this. But it's okay. Like you can take 2 or 3 questions like this, put them together, and you may get one IOQM question maybe. So this is still valuable. Okay, this was question 10. Then question 20. Okay, both of you have got it. Anybody else? 20. Okay, few students have got it. I will not solve it myself. M plus I. And importantly, M and N are going to be distinct. Otherwise, every value of integer will work, right? Okay, so anybody who can tell me? Yes. Yes, one.
So m divides n, and m and n are non-zero,
Yes.
positive. So m will be less than n.
Yes.
Now we want to find the minimum value. So as m increases, n will also increase. So the minimum value is m equal to 1.
Mm-hmm.
So we now get that 1 divides n, 2 divides n plus 2, and 2 divides n plus 2.
Mm-hmm.
And no, 3 divides n plus 2, and so on.
Yes.
So we can write n plus I as n minus 1 plus I plus 1.
Okay.
And I plus 1 divides I plus 1. So I plus 1 must divide n minus 1. So
Okay.
n minus 1 is the GCD of all I plus LCM of all I plus 1.
Okay. But I think maybe we are making the mistake of saying that because you chose m to be as small as possible. So for that only you will get the smallest value of m plus n. Can we be sure? Maybe somebody can choose a slightly larger value of m, but because of that the n reduces. So overall the sum m plus n may reduce. Is that possible?
But
I mean, intuitively it seems like it should not happen, but can we prove that? That is the maybe in pre-RMO you can. I think your what you're saying is correct. You will get the answer, but logically, I think there is a assumption we are making that choosing the smallest value of m will give the smallest value of m plus n. Is that can we justify that? But otherwise, did you follow what Rohan is saying? That first, like if I put I equal to 0, then m is a factor of n, and m will be smaller than n. So smallest value of m I can choose is of course 1. So if I choose m equal to 1, then this is just going to be 1, 2, 3, 4, 5, and so 1 to 5, and then for each of them I need that basically to get kind of a factorial kind of sequence there, right? But the question is, can we be sure that we cannot do better? Any other suggestions? What can we deduce from this? So one main difficulty about a question like this, we are very used to when one term divides another term, right? We start thinking in terms of modulus, congruences, divisibility. all of that works if the divisor is constant. This is the really, I could say, worst nightmare where the divisor changes. And like traditionally we know that there is no correlation between consecutive divisors. Like consecutive numbers will have the same remainder. Like if I go from n to n plus 1, but if I keep the divisor constant, I know the remainder will increase by 1. But if I have any number, like if I divide some a divided by b, and I get some remainder r1, and now I divide a by b plus 1, and I get a remainder r2. In most cases, this r1 and r2 may have no correlation at all. Like changing the divisor is the hardest thing that we can do. That is what makes this question difficult, that the divisor is changing. If the divisor were not changing, then we have all sorts of things. Like if two numbers are divisible by the same number, you can add, subtract, all the nice congruences, everything works out. But the divisor is changing. That is the difficulty. Okay, so the divisor is changing. That is very unfortunate. Can we at least make sure that the RHS does not change? Because both are changing. Even if one of them stays constant, then we can start to make some progress, right? Yes, Raghav?
Yes, sir. So we can we can see that m plus I would divide n minus m.
Yes, right. So the idea is to get rid of that I. The I is the one that is changing, right? So why don't we just get rid of it? So what we are saying is that m plus I divides n plus I. But m plus I also divides m plus I, right? M plus I is of course its own factor. So it has to divide the difference, right? So therefore, and we have assumed that m is less than n, right? So therefore I'll get m plus I divides n minus m, and for all I going from 0 to 4. So now at least there is some stability, that this part will remain constant. This is still changing, but at least so now we are getting like 5 consecutive factors of the same number, right? M plus 1 up to m plus 4. There are 5 consecutive divisors of the same number. Raghav, how do we proceed from this?
So basically, since you have 5 consecutive numbers which are dividing n minus m,
Yes.
n minus m has to be a multiple of 60.
It has to be multiple of 6. Why?
Because like in five consecutive numbers, like one of them would be divisible by 4, one of them would be divisible by 3, and one of them would be divisible by 5.
Yes, correct. Yeah,
Yes,
that makes.
so and then you
So
just sorry, sir.
6. No, so it has to be multiple of 60. Okay, got it.
Yes, sir.
Yeah.
And then since you want minimum possible m plus n, you set n minus m to be lowest, and then you set m also to be lowest,
Okay.
and then try to work with it.
Okay. Yes. So the first part I understood that. So what Raghav is suggesting, that m plus I, if you have a number of consecutive terms, then one of them has to be even, one of them has to be a multiple of 3, etc. So you use all those things, then we can conclude that basically out of these numbers, so from m to m plus 4, what can we guarantee? That there exists a multiple of 3, 4, and 5, right? Because these are 5 consecutive terms, so one of them has to be a multiple of each of them. So if I take the LCM of all these, so that is 60, right? So 60 has to divide n minus m at least, correct? And so 60 has to divide this. So therefore 60 divides n minus m. And then I think at this point again we are doing something similar to what Ruan said, right? That we are kind of looking at the factors of 60, then we know that 1, 2, 3, 4, 5 can be the possible candidates, right, for m. But I'm like, if I were to write this question for RMO, I'm still not convinced that how can we be sure that some other value of m will not give a smaller number.
Sir, excuse me.
Yes.
So we can see that we can write n plus m as like n minus m plus 2m.
Okay.
So if you want m plus n to be minimum, we have to
Mm-hmm.
minimize n minus m and m.
Yes, but when you have two variables to minimize, what do you mean by how to minimize two of them simultaneously? Some of them they are conflicting at times. So that is
So I
difficult.
could not hear you. Your voice was breaking for me.
Oh, sorry. Uh, I understand what you're saying. So n minus m, we can write m plus n as m plus n can be written as n minus m plus 2m, right? And so what you're saying, let us try to minimize this as well as this. But
Yes, sir.
can we minimize them separately is what I'm not sure, because see the same in a way, if you think about it, when you try to minimize 2m, you will try to make the value of m as small as possible. In that process, this term will increase. So they are conflicting in that way. So how do we minimize both of them together? That I am not
So
sure
maybe I
about.
think we can first minimize n minus m, which would then after
Okay.
if when we set a value for n minus m, then the minimum value of m just works. Like
I
because
mean,
if you take so n minus m smallest possible value can be 60.
yes.
So, and but if you go one beyond, say if you go to 120, the minimum value of m would be just 1.
Right.
So that would be greater than whatever value you might get with n minus m to be 60.
Yes, correct, correct. Okay, so some kind of estimation can work, because the thing is, now that we know 60 divides n minus m, so there are the value of n minus m has discrete changes. So like for example, the first value that n minus m can take is 60, right? And the next value is 120, and so on, and after this it will keep increasing. So so this is sufficient to see, because if n minus m itself 120, then m plus n will be even if n minus m is itself 120, then n plus m or m plus n will be even greater than that. And so if the first itself we are getting a value of m plus n which is less than 120, then we are done. Okay, that is fine. So I mean, to be honest, even I don't think I thought through this entire process while setting the question. But yeah, it's good to think that if the same question is asked for RMO, see, you don't want to lose marks because you wrote an argument which looks correct, but actually there was a technical flaw, right? So just to know how to write it so that there are no issues like that. So yeah, this I agree that this is a good way to complete argument. Okay, that because n minus m, if I don't choose it as 60, then the next possible value is 120, which is much greater than the m plus n we are already getting. So that is sufficient. Okay, anyway, but I mean, for a pre-RMO paper, you don't have to worry about these things. Just once you observe the 60, then you can simply choose m equal to 1, and then n is equal to what?
N would be 61.
61, right? So this is the answer. So answer was 62, I just. Okay, this was question 20. Okay, any other question?
So question 8.
Question 8. Okay. So question 8, you need to minimize. Oh, sorry, maximize. Yes, Kana.
Because y is greater than or equal to x, we can get rid of the absolute value signs in the numerator, and the numerator simplifies to x.
Yes.
So x should be as large as possible. So x would be equal to y because y is the upper bound on x.
Right. Correct.
Then we would have an expression in y that we can minimize easily.
Yes. Yeah. Yeah. Makes sense. Okay. Do you follow what he's saying? That firstly, that because that absolute value was completely useless because this is already given. So this we definitely know will take the positive value. So this will be simply y minus y plus x. So x upon y cube minus 2y square plus 3y. So we can get rid of the absolute value. And then observe that as the value of x changes, how does the numerator and denominator change? And so very conveniently, if x increases, the numerator increases, which is good, and the denominator decreases. Only caveat is that when the denominator decreases, we have to check the signs, right? Whether it's positive or negative. Because in terms of if the let's say the denominator is negative and it is decreasing, then actually the absolute value is increasing, right? So I think we have to be a bit careful there. Do you understand my concern, or no? That
Yeah.
when we say that x increases, as long as the denominator is positive, what you're saying is correct. But can we be sure the denominator will be positive? So how can we make sure of that? I think we can be sure denominator is positive. Can you see that also? Why? How can you rewrite the denominator in such a way that we'll be sure it will be positive?
Y is greater than x, so y minus x is one.
Yes, correct.
And lesser than 1.
Yes, correct. But
So
we
numerator
no numerator is positive. What about denominator? The question is because at this point what we are arguing is that if I increase the value of x, that numerator increases and denominator decreases. But the denominator decreasing is a good thing only if it is positive. Okay, this goes back to some very basic what can I say identities that you need to know that. I mean, for example, if a and b are both positive and c also, or x, they are all positive, then consider the fraction a upon b and a plus x upon b plus x. So you're adding the same number to both the numerator and denominator. So do you know what happens to the overall value of the expression?
e plus x by b plus x is greater than a.
A plus x by b plus c is greater than a plus b. Okay. No, why? Yes, correct. It is correct because if I cross multiply. But then, so that is where a is less than greater than b. But if it is the other way, like if the numerator is smaller than the denominator, right? So consider this. Now it's b by a and b plus x upon a plus x. Now what happens? Now if you cross multiply, you'll see that it is the reverse. So for fractions less than 1, adding the same term to both numerator and denominator takes it closer to 1. For fractions greater than 1, again adding the same number takes it closer to 1. But because it is greater than 1, going closer to 1 means decreasing in value, not increasing in value. Okay, is this clear in your mind? And you can take very small examples to understand, like intuitively. Like for this one, consider fraction as 3 by 2, right? This is like 1.5, where the difference is 1. But now if you consider a much larger fraction, like 101 upon 100, here the value has decreased, right? Because we are much closer to 1. And we are still greater than 1, but we are much closer to 1 now. And here the reverse will happen. Like if I take 2 by 3 and 100 upon 101. Right? So I hope everybody understands these things. But now all of this was for positive ABX. What happens if I and I mean for this problem much more relevant is the obvious statement that if I increase the numerator and decrease the denominator, obviously the value will increase. So a by b, if I compare with a plus x upon b minus x, right? That is what this expression is like, where the numerator has positive x and denominator has negative x. Then in this case, it is clear that this is like this, because if you cross multiply, you will get minus x on this side and bx on that side. But all of this is happening because of this. What if the denominator itself is negative? Like what if I get a situation where, let us say a, it is like this, a is greater than 0, is greater than b. So now b is negative, a is positive, and let us continue to say x is greater than 0. So now if I compare a upon b versus a plus x upon b minus x. Okay. So how do you compare this? I mean, if you cross multiply here, that would be the first mistake. Because when you cross multiply, you are multiplying by the denominator, and if the denominator is a negative number, then the sign changes, right? So how do you evaluate this without cross multiplying?
I can prove that the denominator will not be negative if we set x is equal to y.
Are you talking about the original problem or this one?
Yeah, the original one.
Okay, we'll come back to the original problem. I mean, there are multiple ways to address that also. But just to make this point clear, that how will you figure out which number is better in this case, in this comparison? So one general rule is that if we are not able to put a sign here, right? We are not able to put a sign here because we are afraid when we cross multiply, the sign will flip. We just take the difference and we start evaluating the difference. Okay. So why don't we do this? We just take the first term minus the second term. Okay. So let us write a on b. So consider this expression and let me call it capital E. So the expression is a upon b minus a plus x upon b plus x. So here I'm not comparing anything. I'm just evaluating. So I'm free to cross multiply. Okay. So then if I cross multiply, what will I get? AB minus. Okay, we get something like this. And now if you look at this expression purely in terms of the signs, forget the magnitude, then what are the signs of all the terms? Like here, obviously you have -1. Here x is positive. So this part is positive, b is negative, right? So that this the negative and minus will kind of cancel each other. So here we'll just have some purely positive magnitude left over. And so finally we want to determine whether this E is greater than 0, less than 0, or equal to 0. That is what we want to find out, because that will determine what is the sign we'll put over here, right? So
Sir, but b minus x also be negative, no?
b minus x will also be negative. Yes, that is correct. Yes. So b minus x will also be negative because b is already negative, and through that we are subtracting one more like positive value. So then what is the only term that will determine whether this whole expression is positive or not? A plus b, right? So, and in fact it is reverse. So if a plus b is positive, then this expression will be negative, because the total number of negative signs is odd, right? We have a minus sign coming here, here, and here. And so basically, depending on the values of a and b, the sign here will be different. It can be either like this, or like this. So depending on the magnitude, because when I say a plus b greater than 0, where one is positive, one is negative, so their magnitudes will make all the difference. Okay. So keep all of these things in mind. Like just don't blindly assume that if the denominator is decreasing, then the value of the fraction increases. That is only if the denominator is positive. Okay, so having said that, in our problem, thankfully, we don't have to worry so much because quite easy it is. One can show that the denominator is positive. So yes, now, what would you suggest?
The denominator will be positive if we set x is equal to y, when y cubed plus 2y will be greater than 2y squared. Because y is positive, we can divide by y and show that this is equivalent to proving that y squared plus 3 is greater than 2y.
Yes. And
But
why is
y
that true?
squared, what? Y,
Yeah.
y squared plus 3 is greater than y squared plus 1, which has to be greater than 2y because y squared plus 1 minus 2y is a square.
Yes. Yes, correct. So the observation is that here there is a perfect square lying in this expression, right? Can you see that perfect square? That perfect square can be used to finish the proof. So our claim is that the denominator is positive. That's all that we need to prove here. That prove that the denominator is positive. So the denominator I can rewrite as see, I want to get rid of what will make this negative, if at all, the negative terms, right? So I want to compensate those negative terms with sufficiently large positive terms. So if I match them that way, that for every negative term, there is a sufficiently larger positive person sitting there, so that that negative term does not have any effect. Then the whole expression will become positive. So like that, what will I do? I will first, to take care of this minus x, what can I use to annihilate that minus x? Up 1 plus y is enough, right? Because we know that y is greater than x. So out of this 3y, I will borrow 1y and give it to this minus x. So I'll write this as y minus x. So 1y is gone. But I still have y cube minus 2y square plus 2y left. So that minus 2y square in the middle, that also I have to destroy using the remaining terms somehow. And it is looking like the middle term of a perfect square. So what I can do, let's say I can take y common. Then I'll have y square minus 2y plus 1 and plus one more y left over. Can I rearrange the denominator in this way? And now it is very clear that this is going to be positive because term by term it is clear. Okay. So I think now what you did also is basically the same thing, right? Because you also got that y square minus 2y plus 1 as the perfect square.
Yes.
Yes. Okay. So I hope everybody is following online also, that how we are sure that this whole term is positive. And so therefore now we can be sure that if we keep increasing x, then the numerator will increase, denominator will decrease, and the overall fraction will also increase. And so we want to maximize the value of that fraction. And so we'll make x as large as possible, which in our case is equal to y. Okay, so therefore it is, if I set x as equal to y, then I will get this expression as large as possible. And in that case, x will go away from the expression, right? I will have only y remaining in my expression. And so then from now it is no longer a two variable problem, it's a single variable problem. So now the question is find the maximum of y upon y cube minus 2y square plus 3y minus y. That is what it will become once I substitute y in terms of x, y in place of x. And y has the same restrictions as before, that y can be from 1 to 10. And now, I mean, y cancels out. And again, what we get is this, right? And this point has become pretty standard question. Like if you know how a quadratic equation behaves, like maximize this, we need to minimize the denominator. And again, same factorization that we saw earlier is going to happen here, right? So this is 1 upon. So the denominator will be minimum when y is equal to 1. Oh, okay. Then I guess there's a mistake in my question. Maybe I should have given y greater than equal to 1. Then I can put y equal to 1. Otherwise, what is happening is y can approach as close as 1 to possible, and the expression will become as keep on increasing, but it will never reach maximum value as such. It will like infinite descent. Yeah. So then I think the mistake in the question was to this should have been greater than equal to. Okay, but I hope the approach is clear. And again, in inequalities, you have to be extra careful about signs. Okay, who had asked this question? I think Om or somebody else.
Yes, sir.
Yes. Okay, this is fine. Yeah, but I think that the mistake in the question may have maybe misled some of you that what is the right approach. But yeah. Any other question to be discussed? 18? 18 like I. There's so many ways to do question 18, right? It is like you can apply cosine rule. You can find a height by 30, 60, 90 rule. What is given? Angle A is 60 degrees. AB and AC are given. And you have to find this altitude. So this is what I have to find out. So maybe I cannot find it directly, but I can find it indirectly, right? By first, if I find the length of my base BC and I find the area of the triangle, then I'm done, right? So like even if you don't want to apply cosine rule, you can just drop another altitude and you'll get a 30, 60, 90 triangle here, right? So you know this. So if I call this first altitude as HA and this as HB HC actually. So this is a convention we use sometimes. H subscript the letter to denote which altitude we are talking about. So we can find HC, right? HC will be half of 0.8. So HC is equal to 0.2. So therefore I know the area of my triangle, right? 0.5. Oh, sorry. Yes, correct. Okay, so I know the area of my triangle, and then what do I do? So I can
We can find HC.
how, but we need to find BC first, right? See, if you apply cosine rule, you'll get BC immediately. But I'm trying to see if you can avoid applying cosine rule.
The HC intersects AB at C, then AD will be 0.4.
Yeah.
So we get that AD is 0.4.
Okay, so then we can apply Pythagoras theorem in this triangle and get it. Okay, that is fine. So we find the HC, right? And we know this length now. This will be 0.4. So in this triangle, we have everything to apply Pythagoras theorem, and therefore we'll get BC. Okay. And there is no reason to avoid cosine rule as such, but yeah, we can do it without that also. Okay, so I don't think there is much in this question as such. And by the way, this is a very famous triangle. You should always remember this triangle. Okay, 5, 7, 8. Remember these magic numbers because they are very useful to set questions. 5, 8, and 7. Because actually, when this angle is 60 degrees, what does cosine rule say? Like if I call the sides A, B, and C, right? In terms of ABC, what is the cosine rule for the side A? So A square will be equal to how much? Minus 2 AB cos 60. And how much is cos 60? 2BC. And how much is cos of 60 degrees? 1 by 2. So that 1 by 2 cancels out. And what you get is equal to B square plus C square minus B into C. And so the question is, can we find nice integers which satisfy this condition? And there are few, that's not, there are, but there are many also. So 578 is a one triple which satisfies that. And you can explore this question independently. What are other triples of numbers, which integers, which satisfy this condition? Just like Pythagoras theorem has a whole family of solutions. In the same way, this expression has a whole family of solutions. And we'll use any of them to construct a 60-degree triangle. And just like 60 degrees, of course, 120 degrees has the sign changes. So for 120 degrees, the cosine rule, same ABC, then it will be simply a square is equal to b square plus c square plus bc. And again, there are some special integers which give this triangle very nicely. Okay. So whenever you see this 5, 6, 8, 8, you can reduce all of these values quickly. Okay. Any other question? And I mean, I don't know if you got time to solve all the questions. Even during the week, if you are solving questions, you can just keep posting them on the WhatsApp group. And first, maybe others can help. And if nobody is getting it, then I will also try. Did you get question 23, the telescopic sum? That is fine, right? Any other question? I'm trying to find some telescopic, some nice problems about that. 26. So do you know the name of this series? Good. And do you know how to evaluate it also? And we have to find F2 modulo 100. Okay, so do you know how do we evaluate this expression? What do that shift and subtract, right? Slide and subtract. So that and if you slide and subtract, this becomes a geometric progression, right? And then that geometric progression again slide and subtract, or if you know the formula, you can apply it, right? So in that way, if I call this S, then to slide it left or right, if I multiply by n, so n times S will be n raised to 100. I mean, either way, I subtract from this to this, right? Or no, what should work, right? Okay, so I slide to the left, and now I'll subtract from n times S, I'll subtract S. So that will be and so then
So it
this
will be
makes-
minus n to the power 99, right?
no, why? From this, I'm subtracting this minus this, right?
Okay, okay. So minus. Okay, so this is what we get as S, right? S into n minus 1. So S will be whole thing upon n minus 1. Okay. So in general, this looks like a very complicated expression, but thankfully we're only interested in f of 2, right? So if I put n is equal to 2, the denominators are going to go away. And so what will I get? And not only that, note that I'm interested in modulo 100. So this minus 100 is also will not make any difference. So modulo 100, I can just say that f of 2 will be congruent to, so 2 times 2 raised to 100 minus 1 minus 1. No, not minus 1. That's all right. Only this much. Everything else will go away. And so this is where you can apply Fermat's theorem, Euler's theorem, if you know these properties. We have not done them formally, but we were knowing these basic properties about indices, like any number raised to, like prime number raised to index, or sorry, any number raised to prime index or composite index. So if you don't know this, just look up Fermat's theorem and Euler's theorem. Fermat's little theorem. Euler and you will see. So although we have not done number theory, I think these are basic things that if you know, then you can solve a question like this. Okay, so the idea is to decompose this 2 raised to 100 in terms of the 5 function of 100. Okay. So 2 raised to or no, actually the right way to do it is we have to split 100 as 4 and 25, and we'll find the remainders with respect to 4 and 25 separately. And if we know both those, then we can combine them to find f of 2. Okay. So maybe I'll just complete this problem, but I'm not sure if everybody is familiar with the techniques involved. So the idea is I will split 100 into its co-prime factors, because from Chinese remainder theorem, what we know is that if I know the remainders with respect to two co-prime divisors, then I can combine them and I'll get a unique number with respect to LCM. Okay, so therefore I can write this as f of 2 is congruent to 2 raised to 101 minus 2 modulo 4 and modulo 25. So same expression I can write in terms of both 4 and 25. And out of that, the 4 one is trivial, right? Because obviously with respect to 4, this is multiple of 4. So all that remains f of 2 is congruent to minus 2 or plus 2. Right? So basically what I'm saying, f of 2 is a number of the form 4k plus 2 for some k. That is what the first line will give us. And what will the second line give us? That f of 2 is congruent to 2 raised to 101 minus 2 modulo 25. And so what is phi of 20? So now that 2 and 25 are co-prime, we can apply Euler's theorem, because what Euler's theorem says is that if two numbers are co-prime, then I can raise the first number to phi of n and I will get the modulus as 1. Okay. So we just need to find phi of 25. So phi of 25 equal to 1 upon 25. Sorry. Okay. So anything raised to 20, like 2 raised to 20 will be congruent to 1 modulo 25. So 2 raised to 20 will be congruent to 1. And so naturally, not only 2 raised to 20, I can raise 2 raised to 20 raised to something. To reach close to 101, if I raise it to by 5, right? So I can consider 2 raised to 20 raised to 5 will also be congruent to 1. 1 raised to 5, which is congruent. And so therefore 2 raised to 100 is congruent to 1 modulo 25. And then from here, it's just a slight adjustment to reach this term. Like if I need to double and subtract 2, right? So I get 0. Interesting. So I get f of 2 is equal to 0 mod 25. So f of 2 is divisible by 25 and it is of the form 4k plus 2. And so like modulo 100, you can see which of the remainders satisfy both of these simultaneously. So divisible by 25 means 0, 25, 50 and 75. These are the only possible values. And out of that 50 satisfies this, right? 4k plus 2 form. So therefore the answer is f of 2 is congruent to 50 mod 100. Okay, I hope my calculations are right. I have a feeling that I do this question every year and I get a different answer every year. But at least the method is the same. So okay, I rushed through this part really high speed because anyway we have not done all of these things, so it will take time to explain. But once you read up about Euler's theorem, Fermat's theorem, these things will become clear. Okay, and I'll also add to that list Chinese remainder theorem. So these are all basic properties about congruences. And in fact, because last year I had done number theory completely, so last year's recordings are there on YouTube. So if you want to, you can go and watch that also. Okay, so that was question 2018. No, sorry, 26. Okay, any other question? Okay, then if we don't have any other questions, I'll just write a few practice questions on board, which we can try now, or if you don't get time, we'll continue discussing on WhatsApp. Okay. But before that, I mean, just to remind you that, of course, you should, next Sunday you have an exam, IOQM. I hope everybody has filled a form. Any other formalities like getting the center details and those things, make sure that you write to the coordinator, regional coordinator, and get those results. In case anybody has not got admit card or you don't know which center you need to go to. So get those things resolved. What time is the exam? 10 to 1. Okay. So, I mean, generally, it's a good idea to try to set your body clock so that you are most efficient during that time. But I guess you'll also be attending school and other things, right? So I don't know if you'll be able to get that exact time slot available to practice. But like try your best to stay alert during that time frame. Okay. And like how are you supposed to do an exam like IOQM? I think the key approach is maximize your efficiency. So what is efficiency? Purely counted in number of marks scored per minute. That is your run rate, right? You have 3 hours. In that, how many marks you can score? You don't have to solve every question, but whatever question you're solving should give the most benefit. Like if you are going to spend half an hour on a 2-mark question, might as well spend that half an hour on a 5-mark question, right? So like you have 2-mark, 3-mark, and 5-mark questions, and you can look at the past papers. Like try to get a judgment that like are my 10 minutes best spent on the 2-mark question or a 3-mark question or a 5-mark question, and that is something that you have to keep evaluating again and again. You have 3 hours to sort of evaluate how am I doing, reconsider your strategy. It's not like you may go to the paper with one strategy that okay, I first do all the 2-mark questions, then I'll do the 3-mark and then 5-mark. That is the strategy in your mind at the start at 10 a.m. After half an hour, you realize it's not working out, that I'm spending too much time on getting very few marks. And in that also, maybe I'm not sure, maybe I made some calculation mistakes. So I got the answer, I wrote the answer, but I'm not sure if my answer is correct. So after spending 10-15 minutes also, I'm not sure if I'm going to get those 2 marks. If that is what you observe, then maybe you have to change strategies after half an hour. And then maybe attempt 3-mark questions. So like you can keep reevaluating what is the best approach in the exam. Don't do it every 5 minutes, otherwise you'll end up only reevaluating. But have a good balance between following a strategy and thinking of a different strategy. And like whatever practice papers we have done so far, or even whatever practice you will do in the next few days, try all these experiments. Are you able to balance your progress? Because ultimately, it's not that every question has to be. You may want to leave a few questions, because if you feel that instead of attempting every question half-heartedly, let me attempt only 2/3 of the paper, but I do it with 100% confidence. So that is the judgment that each student has to take on their own. Okay. And after the paper, so I want to say something about, so I actually like that you're helping each other out in solving doubts and those things, because that is what will make you better problem solver, better students. Actually, one suggestion I have, that when somebody is asking a question on the WhatsApp group, you should also post at least briefly what is the attempt you did. Don't just say question 10, question 7, and then somebody else will come and solve it. Be helpful for the other person, that what did you try, where did you get stuck? Because maybe you have already done 90% of the work, and the last 10% is remaining, which somebody can come and help you. Okay, so you don't have to ask somebody to write the whole solution for you. Or sometimes it's the reverse. I don't know where to get started. So somebody can give you the right approach, that use induction, and then you know how to apply it. So like that, be proactive in helping each other, or rather be proactive in taking each other's help. That ask and the broader implications of this is that this is going to make you better students, of course. But this is also going to make you better teachers. And like, why should you become a teacher? So it is like that serial, क्योंकि सास भी कभी बहू थी. So like I was where you are 20 years ago. So if you extrapolate that, you're going to be where I am 20 years from now. Some of you, I hope all of you. And so if you want to become better trainer, you don't have to wait for 20 years. You can start now. Right? Be each other's trainer, helper, or maybe somebody junior to you. If you are in 10th standard, help somebody who is in 8th standard. If somebody is in 8th standard, help somebody in 6th standard. Okay, so you don't have to wait for to, I'll get a degree, I'll get a job, I'll get settled, and then I'll start teaching somebody. Doesn't have to be that way, right? Okay. But anyway, this is not the best time to talk about it, because next week you have an IOQM exam. But after that, I hope you continue to interact with the students in this way, and that will make the job of us as a trainer also much more efficient, because we know that you are helping each other out, so that we know what are the strengths and weaknesses that we need to address better. Okay. But yeah, so please continue to interact on the group, and yeah, well, not just about the questions, even the theory, that any topics that you feel that maybe you read something nice, you want to share with others. Yeah, please do that on the group. Okay, so that's an open forum for everybody to interact. Okay, but we still have 1 hour, so I will share a few practice questions for us. So I'm just going to pick random questions. I'm not thought about them first. And maybe you have solved these questions before, then that is fine. But if you're not, you can try them out. But I'm just going to be directing my x plus y. So this is a symmetric sum. Should I call it symmetric or cyclic? Let me not write anything. Basically, there are 3 terms. In every expression, there are 3 terms. This last question I also didn't understand fully. When alpha is the root, so is alpha square minus 2.
Excuse me, sir.
Yes.
Sir, I got the answer for the second, like RMO 2008 wala question.
Okay. 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 Shall we discuss the first question? Can you raise your hand if you solved it? Anybody online? Anushka. Yes. Okay. What is the first that you use?
Yes, sir. So first, I basically wrote the equations and then I wrote x plus y as 2 minus z, y plus z as 2 minus x, and x plus z as 2 minus y.
Okay. Yeah. Okay.
Uh,
That.
yeah.
Yeah. Or yeah, you can calculate sigma 1, sigma 2, sigma 3.
Yes,
Or
sir. That's what, yeah. After that, I use the equation 1
Hmm.
and x plus y plus z to calculate sigma 1 and sigma 2. And then from the second equation, that is x square plus y plus z, that one,
Mhm.
I calculated sigma 3 and it came out to be 0. So then I formed a cubic equation and I got the roots as minus 3, 1, and 0.
Okay. And in any order they can work, right? Yes. Okay.
Yes, sir.
Yeah. 3 minus 1 and 0. Somebody is getting a different answer.
Sir,
Three.
even I got 3 minus 1 0.
Okay, maybe
Yes,
Yes,
even
sir.
I
Yes,
got
sir.
3 minus 1.
3 minus 1 and 0. Yes, sir.
okay, fine. So yeah, I think all the methods are valid. Just one or two ways will I can indicate where you can try to approach this question. Yes, Raghav.
Yes, I raised my hand. I had the same method.
Okay, same. Okay. So apart from direct elimination, there are one or two interesting approaches. One of said that is a very nice substitution that you can take x plus y can be substituted by 2 minus z. That kind of substitution. Actually, much more generally, there is a substitution which you should always be uh, aware about. That is the triangle substitution. Do you know there is a name for this? It's called Ravi substitution. Have you heard this term? Ravi substitution. Because what happens is here it is not relevant, but uh, sometimes we are given that ABC are the sides of a triangle, and so that adds a triangle inequality in your context. You cannot take any values of ABC. So to get rid of that complexity, you can have a substitution which does not require the use of triangle inequality. And so like one substitution is like this. And here it naturally seems to be a good idea that why don't we change the variables from x, y, z to these variables, x plus y plus z, and z plus x. Okay, let us make these as new variables. Okay, so and what we often use is this is A, this is B, and this is C. Okay. And the motivation for this comes from our in-circle configuration where this x, y, z are going to be s minus a, s minus b, s minus c, basically. Okay. So for example, now if you add, you will see that x plus y plus z will be a plus b by plus c by 2, which is s, right? And so now I can express x, y, z in terms of ABC, right? So x will be nothing but s minus a. And the reason why this may be a nice idea here is because everything is in terms of x plus y. Apart from this term, right? This x square which is here, everything is written in terms of x plus y. So therefore, why instead of writing x plus y again and again, we are making this substitution. We'll call them ABC. So if we do that, our original expression becomes something like this, right? So the first information x plus y plus z equal to 2, that can be simply written as a plus. If I multiply this whole thing by 2, right, I'll get x plus y plus z, z plus x. So a plus 2 to 4, or equivalently s is equal to 2. Same thing. Okay, so that is what the first condition gives us. The second condition simply gives us sigma 2 for AB, right? So now I'm going to try to find values of ABC. So when I say sigma 1, sigma 2, they are for ABC. So therefore sigma, so this is already I found sigma 1. Now sigma 2 is directly given from the second expression. Sigma 2 is 1. So I know sigma 1, sigma 2, and now sigma 3 I can evaluate because here now the only term substituted is x. Instead of x square, I get x minus a. Everything else is already nice. So I want to get sigma s minus a square into a. So this kind of cyclic sum, if you expand, what you'll see is that a cube will emerge out of that, right? So like I'll get sigma like a plus b plus c times s. If I group the first term, s square, sorry. Then minus 2s sigma a square and sigma a cube. This is what this will expand into term by term, right? And so out of that, everything is I know, only sigma a cube is unknown. So I can find sigma a cube, from that I'll get sigma 3. So once I have sigma 1, sigma 2, sigma 3, that is done. Okay. So like few variations are there, but mostly any approach you try, you are mostly going to get the answer. Okay, so then that was the next question. Are you trying? I'll wait for some time.
Sir, I got the solution for the second question.
Wait for 5 minutes.
Okay. Sir, also I don't exactly understand what the third question is saying.
It is saying that consider this quadratic expression x square plus ax plus b equal to 0. Whenever alpha is any root of that, alpha square minus 2 also should be a root. And
But sir,
under
like,
that,
can't we just take any value for alpha and then form a quadratic?
yes, but uh, the point is now alpha square minus 2 can be taken as the new alpha. So for that, I can plug this value into alpha, and so that chain will keep continuing, right? So as such, we'll get an infinite set of numbers. That is the kind of the trick in that question.
So
Are you following this?
I could not.
Maybe I'll repeat myself. So what I'm saying is that if alpha is the root of that expression, I mean, like, alpha can be chosen as any root of that expression. In that case, alpha square minus 2 also should be a root. And then alpha square minus 2 is a root. Then alpha square minus 2 whole square minus 2 will also be a root. So you're going to get a whole sequence of roots that way. But of course, it's a quadratic, so it cannot have more than 2 distinct roots. And that is how you have to use somehow. Yes.
Okay, sir.
What to say?
Thank you.
Yeah. Got the second one. So I think it is a 90-degree, right? Yes, Kanav, you got it.
Yeah.
So before talking about the solution which I already got, for those who are still trying, what should be the focus of your attention? That, oh sorry, I wrote AB plus AI is equal to BC is what I know. So this AB and AI is the solution which I'm talking about. Whenever you have this kind of a broken segment, right? You always try to join it back together. Okay, that is the idea. And so how do you join this segment back? You just take this AI and rotate it, right? You complete that triangle. So that will look something like this probably. You extend BA. Oh, sorry. And you extend it to the point where you get a, I call this point D, right? So then what I know is that BC is equal to AD and AI is equal to AD. And we would like to make use of that. So for those who have got this is this the idea that you used? Okay. Online is the same idea, or you have any other approaches?
Same
I
idea.
extended AC instead of AB, but otherwise it was the same.
Okay, you extended AC instead of AB. If you extend AC, how will you use that? Can you explain?
AB is equal to AC, so if we extend AC to some point D such that
Okay, fine. Okay, I mean, okay, similar. Understood. Okay, so what does that give? That because this BC is equal to BD, how will that help us? So we have to use all the information that is given to us. That I is the in center. So and not only that, it is the in center isosceles triangle. So I already has special relation with the symmetric. The fact that IB and IC are equal. And now that this BCD triangle is also isosceles. So what will I make I become for triangle BCD? Do you see I will be equidistant from all three? So I will get IB equal to its circumcenter, right? So I is the circumcenter. Triangle BC. Doesn't look like that in my diagram, but I guess once I found the answer, I should draw BSC more like Let me do that actually. Okay, so this I is the circumcenter of. So if I is the circumcenter, then that allows us to compute some angles, right? Because we want to make use of this fact. AI is equal to AD. If you don't use that, then there's no point. Obviously, any isosceles triangle will have a circumcenter, but the speciality is that I is also like this equidistant thing is the most important thing. So if we compute these angles, right, and equate them, we'll get some equations. So we can assume, and everything can be characterized in terms of a single unknown variable. So let us say we call this angle x ABC as x. Then can we find everything else in terms of x? So for example, how much is angle? This is 90. So angle IAD. This angle will be
Sir, how did you get IB is equal to IC is equal to ID?
IB and IC were already equidistant, right?
Yes.
And I is also on this angle bisector. So by symmetry, IC and ID will be equal. Because now triangle BCD is isosceles, right?
Okay.
So
Okay, sir.
because for isosceles triangle, this is everything. This is altitude, this is angle bisector. It's on the same line. Okay, so angle IID is 90 plus x, right? Which other angle can I compute? Can I compute angle ADI? How much will angle ADI be? How do I compute that? So we can compute it this way, right? Because this angle x is there originally. So this angle will also be x because the half of the central angle. And so then this angle is 90 minus x. And then this whole angle is 180 minus x by 2. So if I subtract that, what am I getting? 40 x by 2, right?
IB is equal to ID fine, because IB is equal to angle ID. So,
Oh yes, yeah. Sorry, that was the easier way to do it. Yeah.
But ID will be equal to 90 plus x.
Wait. What did you say? Can you repeat that?
IB is equal to ID, so angle ADI will be x by 2.
But then why are we getting 45 and x by 2? No, I think it's only x by 2. Yeah. There's no 45. 90 can cancel, right? It's x by 2. Yeah, and that's a much simpler way to reach that. We don't have to go through such a long cut. This angle will be equal to this angle, right? And so then the only angle left is AID. So how much will AID be equal to? No. I mean, that we know from this, but can independently find AID. Then we can equate that and we'll get some equation, right? So how much is AID equal to? So note that I is the circumcenter of triangle BCD. We have to use that.
The ID, ID equal to ID is not.
No, but we can deduce that, right? Because IB and IC are equal, and I is on this angle bisector, perpendicular bisector of this main triangle.
Yes. 45 minus x by 2 equal to x.
Well, how are you getting 45 minus x by 2? You are correct, but where are you getting 45 minus x by 2?
90 minus x by
Yes, Rohan.
Sir, will TI equals 2x and that angle perpendicular. The CR is perpendicular.
Yes.
So find out 90 minus x by 20 can find AID.
Yes. So we know all the angles at this point, right? So this angle is 2x. This angle we can find. So how much is this angle equal to?
AI is equal to 8, so we can apply triangle angles and property triangle 8.
Yeah. So that's what I want to do. But for that, I need to find it independently first.
But already AI is equal to 8 degrees.
Okay. So
Two
okay.
angles are equal.
Okay. So what is the next step?
And AI is
So angle AID is x by 2. That I agree. But then how would I use that? I need some other way to compute AID. Then I'll get equation. So what Ron is saying, I agree that this angle CID is 2x. And so only this, if I call this point T, then TIC, this angle, if I find, then I'm done. And I think I can find that angle, right? Because like this whole angle BIC, I know. So angle BIC will be, or rather, I mean, I can say angle CIT is equal to this opposite angle because I is the circumcenter, which is 180 minus x. So I can compute all the angles at the vertex I now. And so I'll get AID. And whenever if anybody has a more simpler approach, we'll come to that also. Maybe we don't have to do so many calculations. But AID will be equal to 180 minus this CIT, that is 180 minus x by 2 and minus 2x. Right? Nine. And so then this AID can be equated with ADI and say this is equal to x by 2. And so we get x is 45.
we get angle IDE.
Yes.
And as IA is equal to TA
Mm-hmm.
and angle IAD we found out at as 90 plus x.
Yes, correct.
So base angle is equal to ADI.
Oh, okay. Yeah, that is a got it.
Then we directed that.
Okay, so okay, got it. So this x by 2 plus x by 2 plus 90 plus x is 180. And we can finish it here. Correct. I agree. Okay, that was a simple way. So once we find ADI is x by 2, then we can just apply triangle AID sum of all the three angles, right? So this is 90 minus x plus 90 plus x plus x by 2 plus x by 2 is 180. And so you can solve for x. Yes. Yeah, we don't have to go through all this CIT and everything. Yes, Raghav?
Yes, sir. I used a different method.
Okay, yes, continue.
Yes, sir. So you can see that angle quadrilateral AICD is cyclic
AICD is cyclic. Why is that?
because angle BDC is equal to 90 minus B by 2 and angle AIC is 90 plus B by 2.
Yes, correct. Yes.
So you can calculate angle. So you have 1 second. Yeah. So since AI is equal to AD due to
Yes.
construction, you have
Yes.
angle AICA equals angle ACD, which is B by 2.
Yes, correct.
Also, ICB is also B by 2.
ICB is also B by 2. Yes, correct.
So your 3 B by 2 equals 90 minus B by 2.
Yes, correct. Yeah.
So now
Okay.
just solve for B.
Yes, it's correct. Yeah. So that's a very interesting observation that angle AICD or quadrilateral is cyclic. Okay. Do you see why? Let me just draw that part of the diagram separately. So because we know the central angle is 90 plus B by 2. and what we call x in our calculation, but it's okay. So this is 90 plus b by 2. The lag is very difficult to deal with. And then because you have completed this isosceles triangle, so we know that this angle is 90 minus b by 2. So therefore, this is a cyclic quadrilateral. And in fact, what you have here is that L point. Do you see that? That this is the center midpoint of the opposite arc. So in fact, this CA is going to be the bisector of this angle. So therefore, this and this angles are going to be equal. That was the observation. Yeah, very nicely spotted. And then basically at this point you have three copies of the same angle, because this is also obviously I is the center. So these two are equal and this. So all these three are at the same point. And then if I join this, then in this triangle the same b by 2 is occurring 4 times. 1, 2, 3, 4. And their sum is 90. So each of them has to be 90 upon 4. There has to be a trigonometric way also, because we know the formula for AI, but I myself have not tried that approach. But does it work out? Okay. Okay.
I did it by taking a point B on BC such that AB is equal to BD.
So then AB is equal to BD. Okay, so you completed the isosceles triangle inside, right? Like this. And so then what you'll get is this segment should be equal to this segment.
We didn't show that quadrilateral is cyclic, so it is an isosceles trapezium.
Right.
And so if that point is K, then IT upon if AI is X, then IT upon IT by TK is equal to IT plus X upon TK plus X.
Yes.
So we get solving that we get IT is equal to TK, so it's 45 degrees.
Okay.
And so the angle TAC is 45 degrees, and so the bigger angle is.
Okay. Yes. Yeah, I mean you can complete the isosceles triangle inside also. That is also. Right. Okay. Any other suggestions about this question?
Then we get a method to try.
Only aspects of the angle, not every angle. Where did the question go? Okay. Okay, so that was the second one. And the third question, although we have only 8 minutes to discuss, but quickly, just to give you the motivation that what is this question about? Looking, it is worded maybe a bit strangely, so don't quickly follow. Yes. Okay. Oh, okay. Okay.
Because
Okay, I see. Can you write your solution properly? I will check it. The idea which I was thinking is that, see, what is the question saying that if alpha is the root of the quadratic, I'm going to get one more root alpha square minus 2, and this chain can keep continuing, right? So that is the main idea which we need to exploit somehow. That obviously quadratic equation will have only two roots, or maybe like two distinct or maybe overlapping roots, but not more than that. So that is what we want to exploit. So we have to look at this chain. So if I call this chain of roots as, let me call x1 as the first root. So x1 is alpha, x2 is the alpha square minus 2, x cube is, so like each xn is the previous term. So this formula, like from going from alpha square to 2, if I keep applying this operation again and again, I'm going to get a whole sequence of numbers. And if you plot that how these numbers change, right? You can imagine, right? Alpha square. So if alpha is already large, alpha square minus 2 will be even larger. And so this sequence will escape to infinity if alpha is greater than a certain threshold. And same for the other way, that if alpha is too small, this sequence will collapse. So there is only one optimum point where this sequence which is stable. And so although this looks like infinite terms, actually there are only two terms cycling again and again. That is what ideally should happen. So that is the motivation for a question like this. So it actually is a question about stability. The stability of a sequence, that how if you have a ball on the top of a mountain and if you push it, it will keep rolling towards that direction. So it is like that, that the number which is already large, you are going to make even larger. So that is the main motivation behind this question.
So then the roots would be -1 and +1, right?
Minus and +1. -1, correct? Why +1?
So basically I started with +1. So if +1 is a root, then 1 minus 2, that is -1 is a root. And then if
Yes.
-1 is a root, which will again imply -1 is a root. So we get only two roots which satisfies the quadratic condition.
Yes, yes, correct. Yeah, something like that.
Here, and there will be two cases, right? One case where alpha is equal to alpha square minus 2, and the other case where alpha square minus 2 or square minus 1 is equal to alpha.
Square minus alpha.
So
That second thing I didn't follow.
that cyclic thing.
Okay. So basically, when the sequence repeats, that there could be one case where there's only one term which keeps repeating infinitely, or there are two terms which toggle back and forth. So both things we have to consider. Yeah, but I think you can complete this question. Okay. So I think we'll stop for today.
So what did he say about cyclicity?
See, right now what we have is what appears like an infinite sequence, but there can be two ways, right? One is that it is a sequence with period 1. So it's the same term repeating forever. Or the second possibility is there are two terms, like first term is the second term and second term is the first term. So both cases we need to consider.
Okay, got it.
So like for example, -1 is an example of the first type, right? Where it will keep on generating -1 forever. But there may be
Yes, sir.
the second case may also have. Okay, but yeah, that's all for today. So all the best for your exam, and of course we'll continue with the lectures after that also, and we'll see how to shift the focus to maybe like we have some theory topics to do, and we also have some problem solving practice. So how do we balance that? We will try to think about that. Okay. Okay. Thank you. Bye.
Bye, sir. Thank you, sir.
Bye, sir. Thank you,
Bye.
sir.